Good morning, everyone. I'd like to welcome you all to the final breakfast session of the conference. And today it is my great pleasure to introduce Professor Detlev Doherr, who is a professor of informatics and geoinformatics of the University of Applied Sciences, Offenburg, Germany, where he's worked since 1990. He received degrees of diploma and doctorates from the University of Göttingen, Germany in 1983. He worked at the German rock salt and potash industry, where he developed a geographical information system for mining and exploration together with IBM. He's served as a professor at Offenburg starting in 1990. In 1992, he founded the Steinbeis Transfer Center of Information Technology in Offenburg, which is part of the German Steinbeis Stiftung. Since 2001, he has been working in the field of digital libraries, internet portals, and virtual environments. He has more than 20 years' experience developing internet-based information systems combined with knowledge bases and artificial intelligence. His current interests include knowledge-based computing, information technology, and the history of natural scientists. So I'd like you all to welcome Professor Doherr. And the title of his presentation is Humboldt's Worldview on the Test Bench of Artificial Intelligence.
Well, ladies and gentlemen, thank you for your interest, for coming to this morning session. It's Friday morning, very early in the morning, but I hope you could enjoy your breakfast. And I try to give you some information about Humboldt's worldview and maybe the consequences he would see depending on our technological developments at this time. Well, in my keynote, I like to point out a technological assessment of artificial intelligence and our understanding of nature. Yes. Well, more than 200 years ago, the scientist Alexander von Humboldt was fascinated by nature and the phenomena observed, which led to a more precise view of nature. With his precise and detailed observations, he founded many of the natural science disciplines, and so he defined our worldview today. Technological progress and the artificial intelligence of highly developed computer systems maybe are upsetting this view, especially when we look at the technological developments themselves and realize the changes they bring for humanity. These technologies cause a change in the established worldview through a new, unprecedented interaction between man and machinery. Well, of course, I don't know what an ingenious mind like Humboldt would have said about the technological developments of our time. But from his writings, one can learn a lot about how open-minded he was about technological progress, but at the same time loved nature in its complexity and beauty, which one must understand with all one's senses. It is therefore time to reflect on nature itself and on our goals in the use of technology and technical progress. Well, technology and information technology are developing enormously and influence our daily lives and society more than ever. There's no example of such an explosion of knowledge, communication, and computer technology in the history of mankind. To make an assessment, we first look at the data that a computer system would be useless without. Saying that data is exploding is like saying the sun rises in the east. It is self-evident. But so big data is an ambiguous term. It's worth mentioning that every category is dealing with his own version of big data. Maybe one definition would be big data is anything which is crashing Excel. Two key consequences of the data explosions are an increasing knowledge gap, which is the difference between collected data on one side and understanding data. The execution gap is the difference between understanding data and action on it. One example, an iPhone is about 100 times more powerful than the computer system during its first space program. But the question is, do we make sufficient use of this technology? Well, artificial intelligence is changing the world and is doing it at remarkable speed. The promise is that intelligent machines will be able to do every task better and more precisely than humans. The developments in the performance of artificial intelligence can be compared by the automatization of human activities and plotted on a time scale. It is not the time scaling what is important, but rather that the computer system will be able to achieve something as milestones. And some milestones are, in about 30 years, bestsellers will be written by computers. Or in 30 to 40 years, computers will replace manual surgery in medical centers. Or another, in 40 years, computers will reach an artificial intelligence that has the same level as human intelligence, and maybe will take over the research on artificial intelligence itself. But what does it really mean when artificial intelligence is not programmed line by line by humans, but automatically by the computer itself, with continuous optimization progress? In contrast, it is naive and dangerous to ignore a technical development that aims at people's living conditions and that could be autonomous in the nearest future. We possibly reach a technological singularity in the nearest future, which is indicated by many authors. In the figure you see the prediction that the computing power will surpass the brain power of humans in 2023 and will surpass the brain power of all humans in 2045. But only computing power is not an indicator of intelligence. The real singularity point will be reached when self-optimization machines would become independent and evade human control. This scenario is described as the greatest and most threatening challenge facing humanity. It is therefore time to reflect on nature itself. I come to the beginning, and on our goals in the use of technology and technical progress. In the simplified overview, our environment is determined by factors such as natural processes, bio and geogenetic developments, evolution, plate tectonics, volcanism, astronomical events, natural climate change, the influence from human activities as our emissions, extinction of species, resource consumption, and finally, the increasing use of computer technology. In computer technology, this connection is not easily and directly observable, as it often only intensifies the processes already mentioned. One example is the use of fossil energy sources such as crude oil or natural gas, which in turn is being expanded through increased computer use by finding and exploiting new deposits, which in turn increase emissions into the atmosphere. More than 200 years ago, Alexander von Humboldt described his view of nature by describing phenomena and processes meticulously and with scientific precision, combining textual descriptions, maps, diagrams, and schemas. He tried to clarify how inanimate and animate nature interacts with each other. In doing so, he developed a worldview that is still valid today. However, he always stressed that nature must be explored and discovered not only through facts, but also on an emotional basis. He believed that a large part of our reaction to the natural world should be based on senses and emotions. The influence of the physical on the moral world, this mysterious reaction of the human mind to the ideal, gives a peculiar character to the study of nature and leads to understandings of natural processes and phenomena which are not only verifiable by facts. It can already be said today that sciences and modern computer technology have dramatically changed our views, our handling of the complexity and diversity of nature, and our understanding of nature because of technological influences on society. For those who are interested in history of natural sciences, this cross-section here through the volcano Chimborazo in Ecuador contains the areas of occurrence and coexistence of plants related to the altitude. With this study, Humboldt founded the discipline of plant geography. By using machines with increasing artificial intelligence, we collect digital data worldwide in unsystematic and rather random sequence and analyze those data with the help of algorithms. This takes place on a machine logic level, which has an increasingly cryptic character and moves away from human feelings and human logic. We can identify 3 generations of analytic factors, which starts with human expertise and a small amount of data, followed by the data-driven analysis. This is the situation of today, where we find big data analytics, natural language processing, and deep machine learning. Finally, we will reach the machine-driven analytics and expertise, which is based on advanced artificial intelligence and prescriptive analytics. We are suffering a paradigm shift in science. This is the situation today. While researchers have so far been able to discuss and influence the consequences of their actions and the use of their technologies, a self-learning and self-optimizing computer system ultimately escapes the influence of its developer by reaching consciousness as an important part of the human cognition, even if we just don't know enough about the role of consciousness, be it in humans, animals, or softwares. We do not know just enough whether it's necessary for complex thought. Regarding the humanism and the influence of the digital systems, we need to ask ourselves substantial questions about digital humanism. Cognitive computing can be expected to constantly improve even autonomous robots, so that in future a seemingly autonomous system can be expected. This is just one example of a development that leads to machines operating autonomously, but strictly according to machine logic. How far autonomy of robots may go? Applied to comprehensive control systems, it seems important to focus on the control problem. However, it is questionable whether it will be possible to commit super intelligent machines to ethical principles, especially since it seems impossible to determine all future situations normatively. From this is an indirect normativity is developed, which gives the machines the ability to select the values to be realized beyond instrumental thinking, for example, in the form of methods of situational selection of relevant standards. However, this would also lead into a dead end because it remains unclear how machine logic could be forced to adhere to this indirect normativity. Of course, it is also part of human thinking that we include social abilities, ecological thought patterns, emotions, ethical and moral principles in our behavior, and even make it directly dependent from them to a not considerable extent. This defines our worldview, and this is the basis of our social behavior. As already mentioned, Humboldt has already explained this in his understanding of nature, which he also based on a precise data and accurate descriptions. Do we need to translate those principles into machine logic? It therefore seems questionable whether our view of the world can at all be grasped and explained by artificial intelligence in view of the problem of emotionless machine logic, not to mention the role of consciousness and the selection of computing technologies and the disciplines of the humanities, which is called digital humanities. Can our worldview be captured by emotionless machine logic? A survey conducted in Germany in 2017 showed that about 1/3 of Internet users considered the legislator responsible for strict measures against the misuse of data. Most of them didn't consider the increase of the potential threat of surveillance of individuals and the tendency to manipulate data through global data misuse. The Internet is growing less free around the world, and disinformation and propaganda disseminated online have poisoned the public sphere. In 2018, for example, the data of over 87 million users were evaluated with political intent and used to influence elections. Since then, further attacks at access and manipulation have become known, and there is a lack of comprehensive security strategy. Over the last 8 years, 18 countries have stepped up monitoring of users on the net without independent control, or they restricted the access of the Internet, often for the weak reason of wanting to stop fake news. The process of personal digital surveillance and the widespread misuse of personal data is reinforced by the increasing use of artificial intelligence in surveilling systems and in the analysis of such data. Well, intelligent algorithms used to analyze large amounts of data, for example, smart grids, smart cities, smart government, already have an influence on privacy, human dignity, and other principles of fairness and justice will ultimately give way to a new arbitrariness because the underlying algorithms cannot function completely error-free. Today's system with artificial intelligence generates decision patterns that always are reduced to a small section of reality and are not limited by intrinsic competence limits. The objectivity of decisions is a fictitious one because objectivity is not related to large amounts of data. This leads to a lack of transparency in automated processes and undemocratic legitimation structures, ultimately to a cybernetic totalitarianism that decides on the form and nature of our society without democratic legitimation. And it's a Pandora's box. The threat of cybernetic totalitarianism. It sounds like science fiction, but have a look to countries that have already introduced a digital surveillance system. The creditworthiness and trustworthiness of all residents will be assessed through individually awarded social points. But it isn't the question how much the way of thinking of artificial intelligence follows humans' logic. It is the fact that primarily algorithms define the decision-making processes. This increases the complexity of the algorithms, and the more the self-learning processes of artificial intelligence have progressed, the less its users can control the machine learning results, which in turn makes the autonomous operating computers uncontrollable. So, we heard some presentations at this conference. The European Directive General Data Protection Regulation, which comes into force in 2018, gives the user the right for explanation of algorithmic decisions. The aim is to design the development of algorithms and evaluation frameworks in such a way that discrimination can be avoided and explanations made possible. With technological development, we are changing our view of nature. which goes back to the natural scientist Humboldt, who was convinced that everything in nature interacts with each other and that nothing is completed isolated. He pointed out that nature must be explored and discovered not only through facts and processes, but also emotionally. What we are currently developing is a purely technical world that attempts to dominate, manipulate, and ultimately determine the worldview in a foreign way by overemphasizing the aspect of machine logic and thus questioning the relevance of humanism. The threat lies in the expected process of machine autonomy and the associated loss of human responsibility in the society. It remains to be hoped we will succeed in implementing our ethics and morals in supercomputers in order to make them independent of negative expectations and feelings. In addition, digital axioms and comprehensive rules, including legal basis for autonomous systems, are needed to influence the interaction between cybernetic systems and biological individuals. This digital humanism should encompass our relationship to nature, our handling of the complexity and diversity of nature, and the technological influences on society to avoid technical colonialism through supercomputers. It is hard to imagine that we can shut down or even destroy autonomous systems that give us advantage or influences, even if we see that the principles of privacy, human dignity, fairness, and justice are threatened in the course of digitalization. But we are still able to formulate the basics for the interaction between computers and individuals, and we are able to implement them as we see fit. This is even more important if we are continuing to take advantage of global data connectivity for our purposes. We need digital axioms and comprehensive rules and laws for autonomous systems that determine human interaction between cybernetic systems and biological individuals. This digital humanism should encompass our relationship to nature, our dealings with the complexity and diversity of nature. We must include social abilities, ecological thought patterns, emotions, and ethical and moral principles into the machine logic to avoid technical colonialism through supercomputers. We do not know exactly when a loss of control over self-learning and self-optimizing machines will occur, but maybe the singularity is closer than expected. Thank you very much for your attention.